Course 3, Lesson 63, we are looking at rational numbers, non-terminating decimals, and percents, and then we're also looking at fractions with negative exponents. So first of all, remember that repeating decimals, this is when one or more non-digits repeat forever. And so a repeating decimal can actually be written with a bar over those digits that repeat, whereas a terminating decimal, it actually ends or stops. So the reason why we use a fraction rather than a repeating decimal to answer questions is because if we were to take something, let's say 0.3 repeating, and multiply it by even just 2, technically, because that decimal is repeating forever and ever and ever, we would never be able to show enough digits to actually do the multiplication fully correctly. But if we show it as a fraction, we can actually do it quite easily. 1/3 times 2 is just 2/3. A lot harder to do when if we are using that repeating decimal to do the multiplication. So how do we go from a fraction to a decimal? Well, if we have something like 5/11ths, we are going to first divide. And of course, the numerator goes inside, the denominator outside. So that when we do the division, I have it worked out right here, we see that it would start doing this pattern of 0.454545 forever and ever and ever. This is a repeating decimal, which we can show. It looks like the 4 and the 5 repeat, so we're going to put a bar over the 4 and the 5. Another one. When we divide this one, we see that it comes out to 0.35. Which means it's a terminating decimal because we get a 0 at the end. We're done with the division. So we just write it as 0.35. This is a terminating decimal. So let's practice a couple of these. 1/8. Well, when we do the division, 1 divided by 8. Well, we're going to need an extra 0 so that we can put, let's see, 8 goes into 10 once. We have 2 left over. Another 0. And we can put 2 8s in there so that we have 16. And we have a 4, which when we bring down the 0, 8 can go into 40 perfectly with a 5. So we are left with 0 as a remainder. And this is a terminating decimal, 0.125. 2/3, well, you might know this one. 1/3 is 0.3 repeating. So 2/3 must be double that, so we get 0.6 repeating. 1/11th also is a repeating decimal, and when you do the division, you actually get 0.1 with the 1 repeating forever and ever and ever. And 7/9, or sorry, I did that incorrectly. 1/11th doesn't come out to 0.1 repeating. 1 divided by 11. We have to add a 0. And we can't do anything there, so we just put 0 and we have 10 left over. We bring down another 0. 11 can go into 109 times, so that we have 99. And we have 1 left over. We end up seeing that when we bring down another 0 there, we're going to have another 0, another 9, a 0, 9. This is actually 0.09 with those two repeating. And 7/9, this is when we have our digit, our 7 that is repeating. 9s often do that. When we take a number and divide by 9, we will get that number repeated after the decimal. With 11s, we do get repeating decimals, but they're going to alternate like this, 090909. Now, what if we are given a percentage like 16 2/3, and we want to put it into an actual fraction, not a percentage, and a decimal? Well, let's first do the decimal. If I have 16 2/3, well, that 2/3 is actually 0.6 repeating, and that's our percentage. Well, to turn it into a decimal, remember, we divide by 100, which often looks like moving the decimal back twice. So we can see that our decimal form of this is 0.16 with the 6 repeating forever. Okay? Now, if we want this into an improper or into a fraction, we first need to turn the percentage into an improper fraction. So to do that, remember, we're going to do 3 times 16 plus 2, which gives me 50/3%. Well, just like we take our percentage and turn it into a decimal, we divide by 100. So we're going to take 50 over 3 and divide by 100. Well, remember that if I'm dividing and I have fractions, I need to copy the first fraction, 50 over 3, and then multiply by the reciprocal, so 1 over 100. What's nice about this one is we actually have some things that we can reduce. 50 goes into 50 once, 50 goes into 100 twice, so we actually get 1/6. That is our fraction. And we can see actually, yeah, 0.16 repeating is 1/6. So we did our job correctly. Let's try it again. Okay, let's try and order these numbers from least to greatest. Okay, lots of ways to do this. Maybe let's turn them all into decimals. And 4/5 is a terminating decimal that goes to 0.8. 83 1/3, well, I could write that as its percent form as 83.3 repeating. So that's easier to turn it into a decimal by moving it back twice. So it's 0.83 with the 3 repeating. And we have 0.83. Now we can order these from least to greatest. And probably the easiest way is to get them so that they all have the same amount of decimals. So we have 0.800. I'm going to go to the thousands. 0.833, and we know that'll go on forever. And 0.830. So that even though these all start out the same, we can see that 800 thousandths is the smallest, so 0.8. And then 830 thousandths is next. And my 833, going on forever, thousandths would be next. That would be my largest. Okay, let's try another set. 16%, we can turn that into a decimal as 0.16. 1/6 as a decimal is 0.16 with the 6 repeating, and then we have 0.165. So once again, I'm going to put these all in the thousandths, so that we have 0.160, 0.166, which we know it'll go on forever, and 0.165. Well, when we look at these, it's a little bit easier to order them now. We can say we have 160 thousandths. We have 165 thousandths. And we have 166 thousandths. Okay. All right, let's use these percentages, turn them into fractions, and use them in order to figure out how many votes were received if they got 41 2/3% of the 1,260 votes. So first we're going to change the percent into an improper fraction, divide by 100, and use that fraction to multiply by 1260. So changing it into an improper fraction, I'm going to take 41 times 3 plus 2. Let's see, 41 times 3, that gives me 123, so plus 2, 125 over 3. And I'm going to divide by 100, so that means I'm going to multiply by its reciprocal. So I can simplify a few things. I'm going to divide by 25 here in each of these. So we have 4 and 5. So when I multiply, I get 5 over 12. 41 2/3 percent is actually 5/12 as a fraction. So I use 5/12 times 1260. And I can actually reduce this a little bit. 1260, let's see, 1260 divided by 12, we can get it in once, so we have 12, and nothing left over, so we have a 6, can't do that, but a 60, we can have 5. So we actually have 5 times 105, because this is 1, this is 105, and so we have 525. They got 525 votes. A lot easier to do that than use the repeating decimal of 0.416 repeating. Much easier to do the fraction form. All right, another example. 16 2/3%. Well, we actually have, let's turn it into an improper fraction, and we have that 50 over 3 again, that we're going to multiply by my reciprocal 1 over 100. So we see this is 1/6. You'll start to remember more and more of these percentages as their fraction forms the more you use them. And now I'm going to multiply by 24, and we see that the tip should be $4. All right, convert the percent to a fraction and decimal, then round to the nearest thousandth. Okay, so 66 2/3, well, that's like 66.6 repeating percent. Move it back twice and we get 0.6 repeating. Well, that's just 2/3. But rounded to the nearest thousandths, I would have 0.66. It's going to go on forever. But if I want just to the thousandths place, that means that the 6 is telling me I need to round up to 0.667. 8 1/3, we have 8.3 repeating percent, which we move it back twice and we have 0.083 repeating, which if I were to continue this so I can figure out to the thousandths place, 0.08333 forever and ever. Regardless if I cut it off at the thousandths place, that 3 on the other side doesn't need to be rounded, so we have 0.83. And as a fraction, I can turn this improper by saying this is 25 over 3 times the reciprocal. So 1 and 4, this is, as a fraction, 1/12. And 22 2/9, well, that's 22.2 repeating percent, which as a decimal is, and rounded to the nearest, as a decimal is 0.2 repeating, so rounded to the nearest thousandths is 0.222. And as a fraction, it's actually just 2 over 9. All right, and last part of this lesson, we need to make sure that we know if we have negative exponents, what to do with them. So remember that when we have negative exponents, to get rid of those negative exponents, we need to move them to the denominator. So in this first case, I can say x to the negative n is actually 1 over x to the n power. 3 to the negative second is 1 over 3 squared, or I can multiply it out to 1 over 9. All right. Now what happens if we have an exponent outside of a quotient, like x over n, or x over y to the negative n power? Well, I'm going to first distribute that negative n to each part. So I have x to the negative n over y to the negative n. And I see actually both of these need to be switched. These x to the negative n needs to go in the denominator, y to the negative n needs to go in the numerator. So I get y to the n over x to the n. So really what I've done is I've distributed and switched their positions. I'm going to do the same for this other one. 1 to the negative third over 2 to the negative third. So I get 2 to the third over 1 to the third. Well, that's really just 8 over 1, so 8. All right, so once again, I'm going to distribute, flip, and simplify. I can do that a little bit easier by knowing that pattern, and I actually, for this one, 1/3, it'll be 1 to the negative 2, and 3 to the negative 2, switch them, and I get 9. 9 over 1 when I simplify. For this next one, that negative 1 on the outside isn't going to change the values. It's just going to change the places, so we have 2 over 3. And lastly, we get 100. You can practice that one for yourself and see if that's what you get. Well, I hope this is helpful for your homework and for studying.